Okay, dear friends, hope that you are all fine and preparing your exam well. Today, we are solving October-November 2021, paper 4, variant 1. Let's start it. Some physical quantities are scalars, and the other physical quantities are vectors. State how a vector quantity differs from a scalar quantity. Very simple difference is vector quantity has direction, while scalar quantity has no direction. So, and this is enough for mark. Vector has direction. Circle the vector quantities in the list. Circle. Acceleration is a vector quantity. Momentum is a vector quantity. And velocity is also a vector quantity. A microphone is in a recording studio, has a mass of 0.5 kilogram and weight W. Calculate weight. W is equal to mg. So 0.55 times 9.8. It is 5.39. So we can round it up to be 5.4 Newton. 5.4 Newton. The microphone is suspended from the ceiling by a cord attached to a small ring as in figure. Here is the ring. Figure 1.1 shows the microphone pulled to one side and kept stationary by horizontal thread. So this horizontal thread, it is stationary. It means it is at rest. It means the microphone is in equilibrium. The microphone is in equilibrium. The tension in the horizontal thread, 8.1 Newton, determined graphically, no more Pythagoras theorem. The magnitude and direction relative to the vertical of the resultant of W means weight and T means tension. And they are kind enough here to give scale of 1 centimeter to be 1 Newton or greater. So we will be using 1 Newton equal to 1 centimeter. So my dear friends, here 8.1 Newton equal to 8.1 centimeter. And 5.4 Newton is equal to 5.4 centimeter. Okay, now we have to do it graphically. So we will be using head to tail rule. We also call it tip to tail rule. Head of the first vector is joined with the tail of the second vector. And then the resultant is obtained by plotting a straight line joining the starting point with the final point. An arrowhead pointing from the starting point towards the end point. Now I'm proceeding it accordingly. But we need to know the direction. North, east, south, west. 8.1 is due east. Weight 5.4, that is, weight is always vertically downward. So I'm starting with the tension, which is 8.1, 8.1 centimeters 8.1 centimeter due east. Head of this vector will be joined with the tail of the second vector, which is 5.4 centimeters. So 5.4 roughly here. 5.4 centimeter. Starting point was this, end point is this. So just join them together, directed from start towards the end point. And now arrow will be pointing from starting point to the end point. And when I'm using, okay, wait a minute. 8.1 Newton, 5.4 Newton, and as I'm measuring the resultant, it is almost 9.7 Newton. And angle with the vertical direction. And this comes to be 55 degrees with the vertical by using a protractor. Now, still explain, okay, by the way, if graphically it was not mentioned, then these vectors are perpendicular. So simply we can use Pythagoras theorem. Right now, it is graphically, so we will use the scale diagram, but by using the rule head to tail, joint, and angle we will measure by using the protractor. Still explain how the magnitude and direction of the resultant in CII compares with the force on the ring due to the tension in the cord. Due to tension in the cord. This is the result. And this is the tension in cord. You can see the resultant is in this direction. So their magnitude are equal and they are opposite in direction. So they balance each other. That's why this microphone is kept stationary. It is in equilibrium. So, dear friends, I'm going to write they are equal in magnitude but opposite in direction and cancel the effect of each other. Okay, for 2 marks. Let's move to question number 2. A student carries out an experiment using plastic beaker that contains 0.24 kilogram of water at 17 degrees Celsius. The thermal capacity of the beaker is negligible. Define thermal capacity. Thermal capacity is energy needed to increase the temperature of a substance by 1 degree Celsius. By 1 degree Celsius. If it was specific heat capacity, then it was energy needed to increase the temperature of a substance of 1 kilogram by 1 degree Celsius. So when it is specific heat capacity. We are specific about mass. Here, it is thermal capacity. So I'm going to write the definition as I have said few minutes before. So it is the energy needed to increase the temperature of a substance by 1 degree Celsius. Part several ice cubes, several ice cubes are at temperature of degree Celsius. They are dropped into the water and internal energy of the water decreases. Give a molecular account of this decrease in internal energy. In exam, you are supposed to write completely internal energy, but here I'm just writing I dot E. What is internal energy? Internal energy is randomly distributed between the kinetic energy of molecules and the potential energy of the molecules. So, so, internal energy is the sum of kinetic and potential energy. As the kinetic energy of water molecules decreases, so internal energy of the water decreases because internal energy depending on the kinetic energy of the molecule. The specific heat capacity of water is 4200 joules per kilogram per degree Celsius. Calculate the decrease in the internal energy of the water as its temperature decreases from 17 degrees Celsius to 0 degrees Celsius. We know equation for energy is mc delta T, mcat. Mass is given, C is given, change in temperature is also given. Mass was given in the very first line. So as we simplify, I'm writing the rounded off answer 1.7 times 10 raised to the power 4. So 1.7 times 10 raised to the power 4 joules. As the temperature of water decreases, some of the ice melt. Explain why this ice melt. So we can say thermal energy is absorbed from water and that's used to break the bonds between the ice molecules. So thermal energy absorbed from water is used to break bonds in ice and it melts. That is enough for Kumar. Describe how to determine specific latent heat of Q. And dear friends, it's no code with us. Insulators from 2023 onwards. Let's move to the next question. Figure 3.1 shows a balloon inflated with air. The pressure of the air at the inner surface of the balloon keeps the rubber stretched. Explain in terms of momentum of the molecules why there is a pressure at the inner surface of balloon. In terms of momentum, very common. Every time the teachers are saying the air molecules, they hit the walls of the balloon and rebound. When they will rebound, bounce back, it means their direction is changed. So the velocity is changed, being a vector quantity. And rate of change of velocity is equal to force. Sorry, it means momentum is changed. And rate of change of momentum is equal to force. And pressure is equal to force per unit area. So I'm writing this all in front of you right now. So, my dear friends, for 3 marks, the molecules of the air collide with the walls of the balloon and rebound, such that their momentum is changed. That is caused by the change in velocity. We know Newton's second law of motion, F is equal to mv minus mu over t, and pressure is equal to force over area. So 3 marks for this one. This equation actually from Newton's second law of motion. How? I will be sharing it with you now. So F is equal to ma, m times acceleration is v minus u over t. When I'm opening this bracket, so F is equal to mv minus mu over t. Mv is the final momentum and mu is the initial momentum. So change in momentum over time is equal to force. That's what we are using here. Now, the volume of the air in the balloon is 630 centimeter cube. Pressure of the air in the balloon is this atmospheric pressure. Balloon is tied to a heavy stone and dropped into a lake. The balloon is pulled down quickly, and the temperature of the air inside the balloon does not change. It means once law can be applied. Calculate the volume of the air when the pressure of the air is this. So now, as the temperature stays constant and we are having two values of pressure, one value of volume, so easily we can calculate the unknown value of volume or final volume by using Boyle's law. Let's solve it now. P1 V1 is equal to P2 V2. So by making V2 as the subject of equation, we are getting equation P1 V1 over P2. Let's place the values there now. If I'm not wrong, on calculation, we are getting the volume equal to 450 centimeter cube. Okay, now the balloon and stone stop moving when the stone hits the bottom of the lake. Of course, they cannot move further down. The temperature of the air now begins to decrease. Very important point to answer this question. Why volume of the air in the balloon decreases as the temperature decreases? So let's write the answer first. So, my dear friends, temperature decreases, so molecules of air lose kinetic energy and hit the walls of the balloon with less force or less openly. So the pressure of the air in the balloon decreases. But the higher external pressure of water compresses the balloon. That's why the volume is decreased. Volume of the balloon is decreased. Let's move on. A tricky question. A train of mass 1.8 is at rest in a station. At time t is equal to 0, the train begins to accelerate along a straight horizontal track and reaches a speed of 20 meters per second at t is equal to 15 seconds. The train continues at a constant speed of 20 meters per second for 10 seconds. At t is equal to 25 seconds, the diver applies the brakes, and resistive force of the train causes it to decelerate uniformly to rest in further 24 seconds. Figure 4.1 is an incomplete distance time graph for this journey. Complete. Figure 4.1 by drawing. It's a distance time graph. Very important. A line to represent the motion of train between t equal to 15 and 25 seconds. And then a curve to represent the motion of train between t is equal to 0 and t is equal to 15 seconds. Let's solve it. 15 to 25 seconds. Because 15 plus 10, 25. It moves at 20 meters per second. So position by mark 15 and 25. So on y-axis, each small square is equal to 20. Okay, my dear friends, I have used 15 seconds and line I started from 120 meters to 320 meters. Why? Speed should be 20 meters per second. Now, speed is equal to distance over time. 320 minus 120 divided by 10. It is 20 meters per second, which is our required speed. That's why you have to use this. Next part is easy. Curve to represent the train between t is equal to 0 to t is equal to 15 seconds. It is starting to accelerate from t is equal to 0 till 15 seconds. Like this. As it is a distance time graph, so between these two green dots, speed is constant. Gradient of this graph is equal to speed. So gradient is constant between the green dots. So speed is constant. From zero from 0 to 15 seconds, the slope is increasing. It means speed is increasing, which means accelerating. I'm sure this is crystal clear to you people. Calculate the kinetic energy of train between 15 seconds and 25 seconds. Speed is 20 meters per second. Mass of the train is given. So just place the values into the equation. Answer comes to be 3.6 times 10 to the power 7 and joules. Don't forget to write the unit. Next, while the train decelerates to rest, it does work against the resistive force and its kinetic energy decreases. So it means work done against the resistive force is equal to loss in kinetic energy. Define work done. So work done is force times the distance moved in the direction of force. And we can write it W is equal to force times this. Use figure 4.1. Determine the distance moved by the train while it decelerates. While it decelerates. Let's go back to the diagram. It starts to decelerate from this till this point. So what is the value here? 300, 320, 40, 60. So dear friend, it's 560. Just two boxes below 600. 560 minus 320. So 240 meters. 240 meters. Calculate the resultant force acting on the train while it decelerates. Work done is equal to energy transferred. So F times T is equal to 1 over 2 mv square. So F times 240 equal to 360 times 10 to the power 7. And F is equal to 3.6 times 10 to the power 7 over 240. It's 1.5 times 10 to the power 5 Newton. So this question is also done. Let's move forward. Explain in terms of behavior of light rays what is meant by principal focus for a thin converging lens. Principal focus is the point on principal axis where all the parallel rays converge after refracting from the lens. And what is focal length? It is the distance from the center of the lens to the principal focus. So both these definitions I'm going to write now, and this is simply a recall memory. You need to memorize these definitions. which is a point where all parallel rays of light focus, converge, or you can say converge after refracting from the lens. Now the definition of focal length, it is the distance from the center of the lens to principal focus. Okay, a lens is used to produce a focused image of an object on a translucent screen. Figure 5.1 shows the object O and its image I. Consider a straight ray that passes from the tip of the object to the tip of the image. From here to here. If joining these two tips and find the position of the lens, mark the position of the lens by drawing a vertical line labeled L from the top of the grid to the bottom. Let's see it. All the data is given, all the explanation is given. So, a straight line from the tip of the object to the tip of the image. The point where the line intersects the principal axis, horizontal line, that is the position of the lens. This is the position of lens labeled L. Okay. Non-figure, draw a ray that passes through one of the principal focuses because principal focus is on both sides of the lens and determine the focal length of the lens. Okay. So again, let's do it. A ray goes first parallel to principal axis and then passes through focus. So this point is the focus. And they want focal length. Focal length is distance from the center of the lens to principal focus. So from here till here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, focal length is 17 over 5. 3.4. By the way, why you did like this? Yet they have given us a scale. 1, 3, 4. 1, 2, 3, 4, 5. 5 squares equal to 1 centimeter. So there are 17 squares. So divided by 5, we are getting 3.4 centimeter as the focal length. Now, object O is printed document. That includes a larger letter R. On sides facing the lens, the top edge of the document corresponds to the tip of O. Figure 5.2 shows the printed document. On figure 5.1, mark a tick in one of the boxes to indicate how the image on the translucent screen Image on the translucent screen, which is semi-transparent, appears to someone who is looking at the screen from point P. Explain why the image has this appearance. Simple is that the last image is inverted and reversed. Why image is inverted? It is real image because it is formed on the screen, and real image is always inverted. Let's move forward. X-rays are electromagnetic waves. Figure 6.1 shows position of X-rays in the electromagnetic spectrum arranged according to increasing wavelength. According to increasing wavelength. Three components of the spectrum unnamed but labeled J, K, and L. State the names of these three components. See the order we must remember. What is the order? From increasing wavelength point of view, gamma rays, X rays, ultraviolet. So J is ultraviolet. Visible light, infrared. So K is infrared. Microwaves and radio waves. State which of these three components has the lowest frequency. Not only these three components, even in the whole spectrum, the lowest frequency is connected with radio waves and highest frequency with gamma rays. Calculate the frequency of X-rays that has a wavelength of this in vacuum frequency. V is equal to F lambda. F will be equal to V over lambda. So F is equal to 1.2 no X-rays. All parts of the electromagnetic spectrum, they move with speed of light in air as well as in vacuum. And here we are dealing in vacuum. So 3.0 times 10 raised to power 8 is the speed of X-rays over 1.2 times 10 raised to power minus 9. As we simplify, 2.5 times 10 raised to power 17 hertz. State one medical use of X-rays. Don't write three uses, only one use. Used in the treatment of cancer. X-rays are absorbed by tumor and tumor is killed. Our tumor cells are killed. Are killed. Something like this. So 3 points, 3 valid marks. Even you can say it can be used to check the fracture in a bone. So then you have to explain accordingly. Suggest one reason why it is necessary to take safety precautions when X-rays are used. So many uses are there and cause burns on skin. That is enough. A plastic rod becomes negatively charged when it is rubbed with a woolen cloth. Describe in terms of particle how the rod becomes negatively charged when rubbed with the cloth. So very simple answer. Name it in terms of particles. Electrons uh, move from woolen cloth to plastic rod. So number of electrons in plastic rod are more than protons. So it becomes negatively charged. Whereas woolen cloth has become positively. B. A light conducting ball is at rest on a metal table. When the ball rod is brought close to the ball, as shown in figure 7.1, the ball jumps up towards the rod. Explain why the ball jumps up. Electrons are repelled to the earth and ball becomes positively charged. So rod is negatively charged. We know, unlike charges attract. By the way, this is not exactly because this is by electrostatic induction. The ball is becoming charged by electrostatic induction, and that is no more in play. Just because unlike charge concept was also there, so that's why I solved it. The ball touches the rod and falls back down to the table. Why this happens? Ball is discharged. Or in other words, ball has become neutral. So force of gravity pulls it downwards. The weight of the ball pulls it downwards. Let's move forward. This is a good question. A circuit contains two fixed resistors, 1, 2, and a light dependent resistor. Figure 8.1 shows that the power supply is a 9-volt battery. The current in the 450 ohm resistor is 0.012 ampere. What is meant by electric current? Shortcut, rate of flow of electrons. Current in the LDR is I1 and current in 800 ohm is I2. I2 and here current is I1. Complete the equation that relates the current in 450 ohm resistor to I1 and I2. See this I2 is current in the battery also because 800 ohm resistor is connected in series to the battery. So as series and the total current in parallel is equal to sum of the currents in the branches. So I can write I2 is equal to current in 450 ohm plus I1. So current in 450 ohm is equal to I2 minus I1. So current in 450 ohm is equal to I2 minus I1. Calculate the power dissipated in 800 ohm resistor. First of all, we must know how much voltage is there across 800 ohm resistor. We can calculate the voltage across 450 because resistance and current is given. So 0.012 times 450, 5.4 volts. As 450 ohm and LDR in parallel, so voltage across both of them is equal, that's 5.4. So 9 minus 5.4 is voltage across 800 ohm. So voltage across 800 ohms is total minus the voltage across the parallel combination. So answer is 3.6 volts. Now power dissipated P is equal to V square over R. That is in 800. So 3.6 square over 800. Answer is 0.0162 can be written as 1.6 times 10 raised to power minus 2 watt. Then, my dear friends, the brightness of the light that is incident on LDR increases. It means resistance of LDR decreases. Explain what happens to the potential difference across 450 ohm resistor. So when the resistance of LDR decreases, it means the resistance of the parallel circuit or the whole circuit decreases. Current increases. So the potential difference across 450 will decrease, but across 800 ohm it will increase. Let me write it. So I will be writing the answer now. So my dear friends, resistance of LDR is decreased because resistance of LDR is inversely proportional to light level. So light level is increased, resistance will be decreased. So total resistance of the circuit is decreased. It means current in the circuit is increased. So we know also that in series circuit, voltage is directly proportional to resistance. So if the resistance is decreased, so potential difference across 450 will be decreased, but across 800 it will be increased to keep the total voltage the same, constant. Let's move to the next question that is on nuclear physics. Uranium 92 235 is radioactive isotope of uranium that occurs naturally on Earth. Describe the composition and structure of a neutral atom of uranium. So we will say what the neutral atom is made up of. Electron orbiting the nucleus and nucleus with protons and neutrons. And then we will write there quantity to get these 4 marks. So I'm writing the answer. So dear friends, electrons orbit around the nucleus while protons and neutrons are inside the nucleus. So this is about the structure of the atom. What about the composition? So composition, the number of protons equal to 92. As the atom is neutral, so number of electrons will be equal to number of protons, that is 92. Number of neutrons, nuclear number minus proton number. So 235 minus 92 equal to 143. So in this way, you will score all 4 marks. You have to talk about the structure and composition both. Another isotope of uranium is U-238. Describe how an atom of uranium 238 differs from an atom of uranium 235. See, isotopes are atoms of the same element with the same proton number, but different neutron number. So number of protons are same in both, 92, but that's the answer. Uranium 238 has 3 more neutrons than uranium 235, or uranium 238 is unstable, more unstable as compared to uranium 235. As the number of neutrons keep on increasing, the instability of the atom also keep on increasing. In a reactor, in a nuclear power station, a uranium 235 absorbs a slow moving neutron and then undergoes nuclear fission, breaks of the heavy nucleus into two light nuclei, 2 neutrons and a nucleus of xenon, Xe 54 140, and a nucleus of an element represented by E are produced. Complete the equation for this fission reaction. First of all, let me complete the symbols of neutrons. Now, total charge number here 90. So here 92 minus 54. 12 minus 4, 8. 8 minus 5, 3. So it should be here 38. Because 38 plus 0 plus 54 equal to 92. So charge is conserved. Now nuclear number. Total 236. 235 plus 1 minus 140 plus 2. Why plus 2? two neutrons are there, and one neutron with mass number 1. So 1 times 2, 2. So 236 minus 142, 94. And in this way, you have scored 2 marks. So 236 before the fission equal to 236 nucleons even after the fission process. Last part of the question, xenon 140, 54Xe 140 is radioactive. It decays by beta emission to isotope Q. Determine the proton number of Q. Before we answer it, changes to Q with beta emission. Minus 1 beta, 54. Here it is 40. So that 140 plus 0 equal to 140. Nuclear number is conserved. For proton to be conserved, 55. Why? 55 minus 1 is equal to 54. And proton number of xenon is also 54. So charge is also conserved. Determine proton number of Q. How much? That is 55. Nuclear number of Q. It is same, 140. In this way, this paper is completed. And I forgot to share with you people in the beginning that I have chosen this paper because 35 out of 80 was A in this paper. So 35 out of 80 marks was A in this paper. So bit tricky because in the beginning, students may confuse or may lose confidence with that parallelogram question or that graphical question. So maybe they couldn't set throughout the paper then. Wish you all best of luck for the coming exam of physics, especially on 9th of May 2025, paper 4. If you think these recordings are helpful for you, please share, follow, and like the channel. If you have not subscribed, subscribe it so that you can get the new videos. And also share with your friends, especially who are going to take external exams this May, June 2025 or October, November 2025. Share with your friends and the world. Stay blessed. Take care. Bye.